Okay, chapter 3.1. So my voice is going, I think. So I'm gonna have no voice for it tomorrow. Okay, permutations with non-ordered elements. Okay, so we have a formula here, n factorial. So this is when remember n factorial is when we're looking, say we had 10 items and we want to arrange them in a row. So we do 10 factorial, okay? The new formula here is n factorial over p factorial, q factorial, r factorial, dot, 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 dot. These letters could be anything, okay? What they represent is overlapping combinations. Okay, so, for instance, if I was trying to rearrange the letters, say B-O-O-K, so book, if I rearrange them in a row, if I switch these two O's, it still spells book, okay? It's still the same combination. So this formula here takes out those overlapping arrangements or combinations. So we'll look at a couple of examples. Okay, Robert F. Falls football team went 7-4-2 on the season. How many ways can this result occur? Okay, so if I had 13 games, and continue it. If we just write out the result, like win, loss, tie, win. If you just write out the letters, and say what order can they be in? Well, or how many different arrangements can be for the 7 wins, 4 losses, and 2 ties? Well, if you win the first 7 games, or win the last 7 games, it doesn't really matter the order. If I were to take this win and this win, and then reverse it, I still get the same combination, okay? So this is how it works. So the top of the formula, so n represents everything, okay? So how many games were played in this example? How many games were played? 13. So we have 13 factorial and the numerator. Did you have it off yesterday? Yeah. Oh, I didn't see that. So we have 13 factorial. In the denominator, we take away the overlaps. And the overlaps are called like elements. So these are called like elements. Would be the total. Okay, so we're take away the overlap or the like elements. So in this case, the like elements are the wins, the ties, and the losses. So we're going to divide by 7 factorial. Which represents the 7 wins. Then divide by 4 factorial, which represents the losses, and 2 factorial, which represents the ties. The wins are like elements, the losses are like elements, and the ties are like elements. So again, if I swap these W's, the combination is still the same. Or if I switch these two, the combination is still the same. So when we divide by the like elements, it takes away all their overlapping combinations. So what do we get when we do this? Oh, wait, I'm gonna show you the long way and the short way. Okay, so if I asked you to show all your work, so you could just go from this to the answer. Okay, plug it on your calculator, it shoots out an answer. If I asked you to show your work, what would I want you to do? I say show your work and then solve or evaluate. John? Expanded factorial, okay? So I'm gonna expand to 13. What would I go up to? Anyone? Just stop at 7 factorial? Oh.
Yeah, we're gonna say stop at 7.
Okay, I didn't see your hand. So 7 factorial, and then 4 times 3 times 2 times 1 times 2 times 1. Okay, so if I say show your work, I want you to expand it. Expand it such that you could cancel out. So you have 1,235,200 in the numerator. Oh no. 520. 1224 divided by 48. Okay, so there'll be 25,740 different ways that the results can occur. So rearranging the wins, losses, and ties. If we rearrange them, the wins, losses, and ties in different orders, there's this many combinations, given that they take away the overlap. Zach, you got it? Okay, I might make a little bit more sense this in the next question. I'm actually gonna do number 3 first, because number 3 is a little bit easier. We'll do number 3 first and go back to number 2. So number 3 says, how many permutations are there in the word sessions? Permutations, how many ways can we rearrange them? Okay, in the word sessions. Okay, so if I have all these letters and I can rearrange them in any order, that will give us the number of permutations. So the number. Okay, so how many letters do I have in sessions? How many letters, Kyle?
8.
Is there 8? 4, 8. Okay, so if I have 8 letters in a row, if I can rearrange them in any way, it's 8 factorial. So 8 letters, 8 different ways, or 8 spots. So 8 options for the first spot, 7 for the next, 6 for the next, 5, and then 4, 3, 2, 1. So 8 factorial. But we now have overlapping letters. Okay, some of the homeworks from chapter 2, when they did the letters, there weren't any overlaps.
Good morning, Robert F. Hall.